So yeah, as Cornelia said, I'm the solution architect at Cloud. So rather than tell you necessarily what products we do and what we sell, I'm going to tell you instead that Cloud A2K is a really passionate team of experienced professionals who work very hard to help companies transform their businesses. We take business systems and translate them into software to facilitate efficiency, reporting, and automation. Now, looking at the rest of the talks in the series, they're all focused on some really exciting topics like artificial intelligence and analysis and BIM and digital engineering. And I'm going to talk about decoupling data, which if you're trying to stifle a yawn already, don't worry, let it out. I won't take any offense. I'm going to try my best to make a somewhat boring topic more exciting. Decoupling data is very important, and it's one of the most important things you should be thinking about while listening to the exciting talks about in this series about AI. Enterprise architecture is at the core of what we do for good analytics and artificial intelligence. And the reason it's at the core of what we do, because we all want AI that looks like this, not this. Okay, maybe not that, but almost certainly not this. So I'm sure you're wondering, what is decoupling? And why would we want to do that to data? When I refer to decoupling data, what I'm referring to is the separation of my data from my application, not in a physical way, but in the sense that an application runs on one server and a database runs on another, but in an abstracted way. The decoupling isn't a new concept, and here's a bit of history. Some of you in the room will know that as we approach the year 2000, even mid to large businesses ran just everything in their business on a single powerful server with maybe a backup server in the corner that got turned on every now and again. Applications, files, and databases all lived together on that one server until someone touched it or just looked at it the wrong way, and a crash prevented anyone from doing anything for the rest of the day on the IT system. So then you got a bunch of happy employees, but usually not so many happy executives. And we realized that it was smarter to buy servers for redundancy and pool resources for certain functions, such as running an application or a database. So we split our servers into more servers so that we optimize for function and reliability and somewhat redundancy. Definite improvement here. So now when one of the servers got up on the wrong side of the bed, it only affected one department instead of the whole business. Then along came virtualization, another boring topic that many IT people like myself have tried to make a little bit more interesting. And we began creating virtual machines for function and application. We also duplicated them across lots of physical infrastructure so that if one server failed, one of those virtual servers failed, the whole application didn't fail. And that made it a lot easier to also roll back updates and test updates in a UAT VM rather than production. And those updates in the past typically tended to break things and once again impact productivity. So that seems like the perfect picture, really. Everything is neatly siloed, protected from failure. IT guys seem to enjoy coming to work a lot more often, and there are a lot less grumpy executives. We have a new problem though, which is that modern software is easier and cheaper to deploy. And we have all these software products, and they all have their specific function. But if I want to create a graph that blends my sales data that's in Salesforce with my accounting data that's in Sage, it'd be great if it was regularly updated without requiring a tribe of people to blend all the data together in Excel on a daily basis. And that should be easy, right? We call it software integration, and that'll copy the data from one system to another system so that I can have my graph and my report updated every night. Unfortunately, I think people are familiar with the story that when you get into the office and ask for your report, and then you're told a Salesforce update ran last night, and that stuffed up the integration between Sage and Salesforce, so you can't run the report anymore. right before the board meeting. And then we have a bunch of grumpy executives again. All right, so all funny slides aside, when I refer to the abstracted version of data decoupling, what I'm referring to is the concept of centralizing your data outside of the mess of applications that everyone in the business uses. This means that the applications themselves will no longer limit what you can do with the data. With this in mind, practically speaking, you can decouple your data by copying all of the data in every business system you have to a centralized location that is highly accessible, redundant, and most importantly, where you own the information. So another dry topic, what is data? Bing's dictionary defines data as facts and statistics collected together for reference or analysis, and things known or assumed as facts, making the basis for reasoning and calculation. There's a third, even more longer dictionary definition there that mentions computers, but we're going to ignore that one today. In the context of the enterprise, data is anything that is stored anywhere in your business systems, and anything that can be inferred by what is stored in your business systems. This can be Word documents, numbers in Salesforce, marketing images, YouTube webinars, diagrams drawn on the whiteboard, or even the scrunched up notes under the employees' desks that have already been copied into OneNote. And every good bit of information is important for reporting and automation. And we want to use absolutely as much of it as we can. Why? Because we want to make good decisions in our business, and we want to have as much data as we can to inform those decisions. So Wikipedia defines data analytics as the process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, informing conclusions, and supporting decision-making. In the year 2021, we can also use software to automate some of the decision-making processes based on the data that's available and certain conditions are met. And that's when we train algorithms to analyze that data for us and make some of those decisions for us, we call that machine learning, or AI. So with a brief understanding of data analytics, machine learning, and initially decoupling, we can finally get to the important bit. Why is decoupling our data so important to analytics and machine learning? And why are we listening to an IT guy nattering on about definitions and the history of the end of the last millennium? It is important because we want our analytics to be correct, always available, and highly flexible. And it is also important because machine learning requires anywhere from 100,000 to 1 million records at a minimum of relevant, clean, and organized data to be effective. And can I please take the opportunity to remind everyone how important it is that we avoid this? It is near impossible to assemble broad scope data sets across the enterprise that can be organized by a variety of categories without centralizing or warehousing the data first. In my experience, it is very difficult to even assemble the data according to timestamps without centralizing it first. While on face value, it seems like this should be easy. Any people who have used Power BI to create reports and dashboards will know that blending timestamps or categories from two different systems into a single column to use as an axis on a graph can be an arduous task. If the data is blended, centralized, and tagged with timestamps in a data lake or data warehouse, picking dimensions or axes for your visual in Power BI or any other analytics tool is no longer a difficult process. If data is cleansed and transformed and loaded into the central repository correctly according to a hierarchy with the proper tagging enabled, the data can also be interpreted using many different dimensions without having to entirely rebuild data sets to suit the purpose that you'd like to use the data for. So some of you may be thinking this is way simpler than it sounds. So let's take a look at the graphs in this slide that I've put up. I bet there's more than one person in the audience who's picking out my fake data here. It's not the numbers that matter. However, instead focus on the axes. The first slide is safety data sliced by multiple different categories, which is by month, project, category, and time of day. This is usually a very easy series of reports to generate from a particular tool that's handling all of your safety data. As usually it tags everything appropriately inside the application. But let's say you'd like to take that a bit further and look at the safety data a different way. We want to take incidents by month and then look at the number of absentee days that are tied to those incidents by month. So now you need to get the data out of payroll to understand the different absentee days that have happened due to safety reasons for that given month of the year. And then you want to compare that to the cost of replacement labor by month. Now, the challenge that you've got here is that these three systems may not use a similar dating convention, and you need to be able to blend those data across into an analytics tool. So what you need to do is have a unified series of timestamps that apply to any bit of the data that's coming in to your analytics tool that you'd like to analyze. And that is actually, for those who have done it before, no easy feat, as you need to strip the dates and provide a unified set of dates across the singular column that all of this data can relate to. But of course, you could take the easy way out here, just copy this data to Excel, which, little secret, that's how these slides have been created, and do something very similar to visualize the data. But now we'd like to take our cost of replacement labor by month and filter that and restrict that down by the project name instead, so that we can understand the cost of safety implications on a project. This is trickier and a lot harder to do even with Excel, because what you're going to need to do now is match up project A in one system with project A in another system, which is great if they both have the same name in both systems, but incredibly difficult if you don't. And this is where it's really important to have a relational table that tells you, project A in one system relates to project A in another system, so that you can appropriately filter when you select project A to restrict down the data. So this is where the concept of decoupling data in a data warehouse comes in. So just quickly talk through this diagram that's on the slide. You've got operational users down in the bottom, and they're interacting with their business systems. So those systems are capturing safety data, they're capturing financial data, they're capturing schedules and operational data, interactions with anybody on site, as much data as you can possibly get, as long as the system is being entered in a digital way, and even if it's not, lots of OCR capabilities to achieve the same goal. That transactional data lives in various systems, and ideally you want to be able to relate this data between these systems so that you can compare it and so that you can analyze it as a whole. That transactional data, for this to happen effectively, you want to copy that transactional data somewhere where you can then manipulate it without impacting the operational system that it's coming from. There are often three components of a data lake that people refer to, and then there's a bit of a misconception that that's going to make a data lake architecture more expensive. These systems ultimately copy to a section of the data lake that others term data hub. That data hub is part of the lake where you can manipulate the data for use of integrations and do transformations. So draw your attention to the lambda symbol for those who don't recognize it on the right-hand side, the 11th letter of the Greek alphabet, and typically used by IT guys like myself to explain the concept of a stream of data coming in from the top and then splitting and going in two different directions. Those two streams are identical, but they are duplicated. That means that you can operate on one stream of the data in one way, one stream of the data in another. So typically, you would want to take your Lambda 1 string and you would want to use that to transform and do joins and figure out how you're going to relate that data back to the integrations of the system, and push that any data that's required that's coming from one system back to other systems so that they have any integrated data that they require for operational purposes copied into their systems. And then you have what's called the lambda2 string, or the second string, and that is a raw but cleansed string where you curate it and you push it to your analytics data warehouse. You also notice in the left-hand diagram that we have this section on the side called master data. Master data is a critical part of the architecture, and that critical part of the architecture is what we were discussing in the previous slide in relevance to filtering by projects. Each one of those operational systems is going to produce data where it is the master or the key, and we need to make sure that we can relate that data between systems to assist in filtering and to assist in being able to relate data between the different operational systems for the purposes of performing analytics. And that's where we utilize a master data repository. And we make sure that we have a means of reconciling and rationalizing that, so that if a project exists in one operational system where it is not the master, that it is imported but not mastered until the system that does master that data pushes data into the master data repository and creates the relationships. Then your string of, let's say safety data that's being copied to your analytics database, that is simply just has a key for the project as it relates in that particular system, which can be used in the master data repository to match against other systems, so that data across operational systems can be easily compared. In the data warehouse, you can adopt hierarchical structures in order to better save the data. A very typical way to do that is timestamping. A big advantage of a lot of these data lake and data warehouse systems is the ability to automate a timestamping and tagging and categorization process, making it very easy to filter data, which previously was a lot more complicated without having done this first. So all the data that comes in is then ready for lots of different purposes, analytics and automation, and it's almost immediately minimizing the cost of new technology and software being incorporated into the enterprise. And this empowers teams within the enterprise to be more agile and pivot if required. So having said all of this, let's go into a little bit more detail on the three most important benefits that a decoupled enterprise architecture will bring organizations. The first being flexibility, the second being risk mitigation, and the third being culture. So flexibility. One of the most important aspects of decoupling your data from your applications and centralizing it is flexibility. A decoupled data architecture, enterprise architecture, gives an organization a wide range of architectural options. You can buy the software that you want and implement the technology that you want and create the reports and the visuals that you want, and I'll explain why. Flexibility when you're considering reporting options. It's important to recognize the different elements that comprise of modern business reports. So that's usually a combination of any one of narration, data analysis, tabular reports, visuals and dashboards, and they're all used as communication tools. Grouping of these objects is best suited to different cases. For example, operational versus management decision-making. We use different combinations of these. Versus performance reporting and versus boardroom data analysis. The more options that you have to leverage that kind of technology that you invest in to create these communication tools, the easier it will be for teams to communicate between each other and ultimately all the way up to the boardroom. If you're comparing different analytics tools and one of them has restrictions by way of how the data needs to be organized or connected to that analytics tool before it's used. Often you'll find that trying to connect those to existing operational systems directly or multiple operational systems directly may severely impact your ability to generate those reporting options. For example, Power BI has some very hard performance limitations around memory and CPU usage, particularly when reports are published to the online version of Power BI. And that is typically because of a lot of transforming and blending that is done in the reporting tool, where you're trying to blend data from different operational systems or Excel files or raw files, where the whole purpose of Power BI is not necessarily to be performing that task. That's the task of the data lake or the data warehouse. And the data needs to be extracted from those particular raw and operational sources first, copied to the data lake, so that then Power BI has a much easier task of trying to extract that data and analyze that data and generate reports on that data. So the next is flexibility and choice in terms of choice of input and output software. So it doesn't matter what industry is considering with this statement. In order to stay ahead, it's important to invest in the right tools to get the job done as safely and as efficiently as possible. With a decoupled data architecture, you can purchase software that leads the field for its desired function, onboard it, and migrate the data in from the legacy system that you were using, and have that software coexist in the entire enterprise architecture very rapidly. This is because the data that you need to get up and running with the new software is readily available to you in your data lake. So there is no need to go through complex export processes or writing complex point-to-point integrations with a variety of other softwares in order to use your application. Instead, you can generate an API managed service that automatically generates an adapter to that particular software, and then it's just a matter of writing the logic to bring the data into your lake and then push any operational data relevant from other systems back into the new piece of software. That enables you to run the new software typically alongside the existing software for testing, and then it also enables you to cut over very easily, as typically that means that you can actually have an almost identical set of data in both systems as you're going through your implementation process. Ingestion and extraction logic as a sole means of implementing a piece of software, with the exception of configuring for your business process, is often a much smaller task and one task of a large list of tasks that typically form a data migration project. So then flexibility in software customizations or integrations. So to take the previous step of implementing a new input-output software even further, let's say you want to customize that as there's particular functions that you'd like to request the vendor to enhance or add additional development for, or even do your own customizations internally for that piece of software. That would, in a data lake environment, rather than trying to figure out how we're going to copy that piece of data to a variety of different operational systems, potentially even then approach those vendors about how to find a location to house that data. This is where you can layer the lake to better incorporate new customizations and functionality in existing software to be used in reports or to be called as one-off points of data from other operational systems without necessarily going down the process of redesigning those systems. And that makes it a lot easier to consider and a lot more cost effective to consider software customizations and integrations as they just become additional layers, link tables, or additional columns in your data lake environment, and they layer on top. Next one is the flexibility to build your own story. And it seems a bit vague and wishy-washy, but I'll explain what I mean. The idea of having a centralized repository of data will encourage your leaders, teams, and customers to view and interpret the data within that lake in their own way to get the best out of their skills. Everyone brings different and often unique blend of skills to the table, and you'll never know what you'll learn from new team members who like to look at things a slightly different way than you do. If you give them a data lake filled with data that they can then change and interact with, or not change, but interact with and report on in their own way, then you never know what type of analysis or different outside of the box thinking or interpretation that you'll get from hearing them. Taking it a step further, our customers are unique as well. and they may want to interact with the data that's in the lake differently to how I suppose you would provide that for them. So the more that you give them the ability to customize their own experience by being able to interact with your data on the customer-facing side and view the data that they interact with you in their own way, the more you encourage them to engage with you in the journey that you're trying to take your customers on. So the last one here is assembling large volumes of information for machine learning. So this is fairly simplistic in terms of the data lake concept, because rather than having to draw and cleanse data out of large operational systems on the fly to build a workable set of data for machine learning in that 100,000 to million record range, instead all that data is already there in the lake for you. And it can be, if you've tagged it correctly with a variety of different categorizations and tags, you can dig into that information and rebuild it and reframe it in lots of different ways with a lot less work, which means that if your original machine learning analysis doesn't necessarily produce the expected result, to reframe that data, to look at it from a different dimension or point of view can be a very quick exercise, because the data is already built and ready in a position where it could be served to the machine learning algorithm slightly differently to achieve a different result. That is a lot trickier to do when you're trying to build that at runtime, because you'll need to consider how you're going to retransform your data to include a categorization from potentially a completely different operational system that was not included in the first data set. And for those trying to do data cleansing and data matching, it can be an incredibly time-consuming process. There are many AI projects that fail because the data set that they require is not available to them, even if the data actually exists within the enterprise. So, next thing, how do we go into setting up our data landscape to mitigate risk, which is a big one for the boardroom. So probably the biggest and one of the things that interests me the most about data lakes and utilizing a decoupled data enterprise architecture is to prevent data lock-in. And that's data lock-in with software providers, but also any system that contains the data of your business. If you have your data lake as a sole repository where you own all of the data within that lake, and you have direct access to that at all times, any data that's copied into it is then no longer restricted to being within that operational system that created the data. And that's a big difference, because that's the difference between a software vendor buying into a software vendor, or a software vendor locking you in. If you try and leave a software vendor that's got an incredibly complex level of customizations and integrations, it can take a really, really long time. And that can often be, if we look further down the bullet points there, like making more applications more expendable. A piece of software causes an operational deficiency of 10% per staff member. That staff member's average salary in your organization is $70,000. So 500 staff at $70,000 per annum, and 10% of that is $350,000 per annum, or just about $29,000 per month. So if you can replace that poor performing piece of software in a few months rather than in a few years, that could be the difference between, under $100,000 and almost $700,000. If you have all of the data already in your data lake and you're able to configure an incoming piece of software quickly, and this depends entirely on the use case, but usually a huge amount of the challenge is data migration and customization, which leads to integration. And that process, while the more the customizations take place and layer over the top of a particular piece of software, the more complex the data migration becomes and the more complex the integration becomes. If the data migration tasks and the integration tasks take significantly shorter. The time to implement a new piece of software and revert from a poor performing piece of software can be that dramatic, of months rather than years. And that can save your business a significant amount of time. So we also want to minimize the risk of poor data analysis or machine learning, which we've sort of touched on before in flexibility. The more that the machine learning or analysis software can target the whole data set, and the data set can be reframed very quickly based on tagging or categorization, the less likely an expensive data analysis or machine learning project or exercise is to fail. And that is, that is one of the major reasons why those projects tend to fail, is they do not have enough records or access to the right data. So the last 2 points here, IT project delivery risk. We've touched on this before as well. This is around, the more integrations and the more customizations that you need to make to operational software where the lake does not exist or the warehouse does not exist, where the software from another system is required in a destination system for reporting purposes. If that data needs to be copied and there is no place to house that data in the destination system, then that could wind up requiring more customizations and more integrations, and that could wind up also blowing out the delivery time of projects. The more that you adopt a hub and spoke based architecture over a mesh of point-to-point integrations, the less risks there are to project delivery. Every point-to-point integration takes a certain amount of time to develop, and in a hub and spoke architecture, each software only needs to be integrated once, and that's with the data lake. From there, you can then do the appropriate transformations, and if you do need to bring another piece of data into another system for an operational purpose, that's just a matter of adding some layers to the ingestion techniques that you use in the destination piece of software to pull the data out of the lake. And then the final discussion is around business process risk. This actually touches on something that we commonly do when we implement new software, and that is that we try to get our business processes to suit the software that we're implementing so that we can implement the new piece of software. When you implement a data lake, you take a lot of, it gives you the opportunity to look at software that fulfills a certain business function, and the more that your data is centralized, the more that you can build, you can design your processes and then specifically pick the software that's going to fill a particular purpose or function, and then integrate with those directly. So my last point is culture. And we've sort of talked about a couple of these things already, but there's a big cultural impact to some of those points. The more dynamic that your organization is, the more that your staff and your customers can engage with the data, produce different results with the data, and bring their own skills to take that data and use relatively easy to use systems such as Power BI and analytics tools to analyze that data and look at it differently. And that empowers the people in your organization to really make good change. Your customers can also then interact with your data differently as well. And when you have a customer that engages with you, if you've got a dynamically driven, a data-driven environment using your data lake, they could actually go and form their own web experience by pulling in their own data sets that suit their needs. So if you consider a home builder, it's kind of like comparing a customer that really wants to focus on aesthetics when they're looking at their house versus looking at function. And they may engage with your software that you use to visualize that to the customer in a completely different way. Someone may want to go, okay, I want to look at this in terms of how do I move through the building, and how much space have I got for my furniture, and how is my furniture organized, versus aesthetics, where someone just wants to know the particular fabrics that are on furniture, the paint, the finishes in the kitchen. And depending on what type of customer you have, if your data can be interacted with dynamically, it could build a completely different experience for them in a web facility that actually enables them to visualize that. This is also something that enables us to be, like a data lake enables us to be agile and make changes quickly. It enables us to pivot, which is the key to digital transformation, to make quick changes, change direction quickly, and ultimately then adopt the software that best suits what we're trying to achieve. And finally, it encourages and empowers our employees. And this is the big cultural shift within the organization, because the more that our staff and our teams can do their own work and pull out their own data without needing to get bogged down in trying to transform it or rely on IT to transform it for them, the more they can contribute with their broad skill sets, and the more they can have a say and an opinion and raise opinions that may actually really benefit an organization for the better. And the more that people have a say, the more this results in an organization that people want to work for. Your customers and your staff can interact with your business in a way that previously they may not have been able to. So we've sort of, as been talking, discussed all of the potential practical outcomes as we've been going through. Statistical analysis and reporting, integrations. These are all things that we can dive into in a lot more detail, but are probably best left for other discussion topics in the future. One of the key things to bring up here is solution architectural options. The more that your data lake is set up to contain all of your data and has good tagging and good categorization throughout, you don't leave any option on the table. You can reform your solution architecture and introduce new solutions and new software to the overall enterprise in a variety of different ways and very flexible ways that other software and doing point-to-point integrations may have previously limited you. If you have a product and you're trying to procure a new product for a new purpose, and you're checking the compatibility lists of your existing software before you implement, that can really restrict you, particularly if that software that you want to implement in your business and integrate with is actually the leader in its field. So the more that you can rely on your centralized data architecture to interact with that software, and then the more you separate yourself from the limitations of the software that you already have. There are also big security implications where the data lake can be controlled to role-based access. It's usually immediately integrated with your login structure, whether that be Microsoft or another type of directory system, meaning that you can very easily provide layered role-based access to the data, but also access to people within your organization and outside your organization, depending on the conditions that you choose to set. So in closing, I think the key thing to leave here is don't design with the idea of buying more software for current and future states. It's almost impossible to build for the future state because you don't know where you're going to be in a few years' time after you've implemented a piece of software, and by then, it could even be obsolete. So instead, design for ideal state. What do you want in an ideal world? And that's usually the ability to, produce all of these things that are listed on the screen coming out of that data lake. You want to encourage good culture in your business and an investigative staff who want to get in there and really interrogate the data that you have to make a difference and offer improvement. And that is best done through centralizing and decoupling the data from the application so that you reduce the limitations that you have on that data. So I hope this talk has been somewhat insightful. And while you're listening to the other talks of the summit that talk about using data in a variety of ways, I encourage you to consider how locked in is your data to the software that you use today? How clean is your data from the software that you use today? And how quickly can your data be reconfigured to suit new ideas and new solutions? And that way, I hope it helps you to achieve some similar outcomes to the very talented host of speakers that are presenting at this conference today. Thanks for listening.